All right, ladies and gentlemen, so far we've been working on exponents, but our exponents have been positive. Our our base can be negative, but we've only dealt with positive exponents. Now we're going to look at, well, what happens if I have an exponent that's negative? And all of this right here, for all positive values of x to the negative b equals 1 over b. So in other words, So in other words, write this in, a negative exponent means turn the problem into a fraction. So what can be said of 3 to the negative 5th power? This tells me, the negative 5 immediately tells me that I have to put it underneath 1. Then I put my exponent, or my base and my exponent down here, and when you do that, you've now gotten rid of the negative sign. So by taking and writing it as a fraction, now you've written it as a positive exponent. You can always do the reverse. So as soon as you're moving it, you're changing the sign, basically. So prove the general statement, x to the negative b equals 1 over x to the b. And this was a misprint. This should say b equals negative 5. So I'm going to fill these in. So this is telling me, this side, I'm going to deal with this side first. Okay? This is saying 3 to the negative 5 power. All right, well, 3 to the negative 5th power, it's really, I should put this in parentheses here. This really means a negative times a negative, which is 3 to the 5th power. Negative times a negative is a positive. On this side of the problem, this is telling me 1 over 3 to the negative 5th. Well, 3 to the negative 5th, I have to write it weird, means 1 over 3 to the 5th. I know that looks weird. If you're not understanding this part, that's okay. But this is really then a fraction problem. If I rewrite this, 1 divided by 1 over 3 to the 5th. Well, what do we do with fractions? We leave, change, flip. So then this is 3 to the 5th. And they match. So it's just kind of a proof here. All right, well, what does this mean? So what is the value of 3 times 10 to the negative 2nd power? So this is telling me 3 times 10 to the 2nd means 1 over 10 to the 2nd. All right, well, what does 10 to the 2nd mean? 10 to the 2nd, 3 times 1 over 10 times 10, which is 100. Oh, this now goes back to that work we did with fractions and decimals. Put this over 1, 3 100ths, which is 0.03. 2 decimal places, or sorry, 2 zeros, 2 decimal places. All right, well, what is the value of 5 times 10 to the 6th? All right, well, let's see here. So this is telling me 5 times negative exponent tells me to put it underneath 1. I can do 10 to the 6th, 10 times 10 times 10 times, right, 6 times, which is really a 1 with 6 zeros. 1, 2, 3, 5, 6. Multiply, you're going to get 5 on top, you're going to get 1,000,000 on the bottom. And if I turn that into a decimal, right, 1, 2, 3, 4, 5, 6 decimal places, 0.000005. Okay. Write the complete expanded form of the decimal 4.728 in exponential notation. So we did this before with positives. So I know this right here, right, is the 1 spot. So this is 4 times 10 to the 1. Now we're getting into decimals. So what we're seeing is that when I have a negative exponent, it's also telling me how many decimal places I need. Oh, right? Negative 2 power, 2 decimal places. Negative 6 power, 1, 2, 3, 4, 5, 6 decimal places. So this is going to tell me for the 7 plus 7, it's in the first decimal place, negative 1 power. The 2 is in the second decimal place, 10 to the negative 2 power. 8 is in the third decimal place, negative 3 power. And again, this is all leading to something we're going to be doing a little bit later called scientific notation. All right, so write an equivalent expression in exponential notation to the one given and simplify as much as possible. So they want it in exponential notation. They don't need us to multiply it out like we did up here in 2 and 3. So negative exponent means 1 over 5 to the third. Okay, the 3 doesn't have an exponent, so it's going to stay. 2 to the negative 4th, this part says put it underneath 2 to the 4th power. Okay, so then I'm just going to put that up there. All right, next page. Let's see what we got. So 1 times 8 to the 9th. So now we're going to take it, they don't want it written like this. They want it just in exponential notation. So now the exponent's in the denominator. When I move it up, it gets a negative. Okay, let x be a non-zero number. All right, that's just telling us because we can't have a, this is going to tell me to put it in the denominator, and you can't have 0 in the denominator, so that's all that that means. So let's see, for up here, right, we know our rules from before. This is a division, so I have to subtract my exponents. So this is really 2 minus 5. So this is going to be 19 to the negative 3rd power. I could write that if I wanted only positive exponents. I could also write it as 1 over 19 to the 3rd. For number 10, so let's see, I'm going to have 16 minus a negative 3, leave, change. This is 17 to the 19th power. It's already positive, I don't have to do anything else with that. Number 11, so this is now telling me 7/5. If I have a fraction with a negative exponent, this just means do the reciprocal. So this is going to be then 5/7 to the 4th power, which I then could write out as 5 to the 4th over 7 to the 4th. All right, so again, the biggest thing you need to remember, I'm going to write it again. Negative exponents mean put it under 1. Turn it into a fraction. Biggest things you need to remember. Okay? As always, you might want to watch this one a couple of times because this is so very brand new. But I think with a little bit of practice, we'll be okay. Any questions? Bring them to class. Have a good night.